Okay, so in this video, we are going to talk about the Bayes rule, spelled as Bayes rule. Okay, so you are already familiar with this equation, probability of A comma B, that is the joint probability of A and B is equal to probability of A given B times probability of B. And we have looked at how you can use simple tree diagrams to understand both the ideas of the joint probability as well as the conditional probability. All right, so let's look at what conditional probability allows you to do. Let's take an example. Let's say I roll a fair dice and I don't show you the number that I've got, and I ask you the question, what is the probability that I have got 4? Your answer is going to be 1 over 6, because you know that since it's a fair die, all the 6 numbers have equal chances of occurring. 4 is just 1 out of the 6 possible numbers, so the probability of getting 4 is 1 over 6. But then what I do is I tell you that, hey, look, I have got a number which is an even number. So now tell me, what is the probability of getting 4? Which means probability of getting 4 given that the number that I have got is an even number. So now you will say that, okay, now my universe, which was earlier 1, 2, 3, 4, 5, and 6, is now just 2, 4, and 6, because I have been now told that the number is even, and 4 is just 1 out of the 3 possibilities, 2, 4, and 6. And so therefore, the probability that I have got 4, given that the number is even, is 1/3. So now you can see that the conditional probability allows you to update the probability of a given event, provided you have some additional piece of information. And this kind of relationship yields a very interesting result. So let us write and see how it turns out. So we know that probability of A comma B equal to probability of A given B times probability of B. Now this joint probability can also be written as probability of B comma A, because it doesn't matter what is the sequence of these letters. As long as they are joint probabilities, I can write either A comma B or B comma A. That's one and the same. But then this can be written as probability of B given A times probability of A. So now if this and this are equal, so are this and this, which means I can write probability of A given B times probability of B is equal to probability of B given A times probability of A. And so that gives me the following equation. Probability of A given B is equal to probability of B given A times probability of A divided by this probability of B. And this is what is called the Bayes rule. This is a very powerful relationship, and that allows you to solve a number of different kinds of problems where the idea of conditional probability is involved.